Okay, so formalizing relations and functions, trying to figure out what constitutes a function and what does not. So by the time we're done, you should determine whether a relation is a function. We're going to talk about what's called domain and range of a function. Domain is what inputs are allowed into a function, and then what outputs you'll get. And we'll talk about inputs and outputs from a particular function or relation. Okay, and then one of the ways we have to determine a function is something called the vertical line test. If we have the graph of a function, then we can use what's called a vertical line test. Okay, some standards there. So some definitions for you. A relation. A relation is any set of ordered pairs. Okay, we're basically going to match up some numbers, match up inputs and outputs, match up x and y, match up x or f of x, and talk about what f of x is in just a second. Okay, but any set of ordered pairs. Okay, a function, a relation can only be classified as a function if that relation assigns exactly one value in the range to each value of the domain. Okay? In other words, for any input that you put into a relation, okay, you should only get one output. Okay, exactly one. We'll take a look at some examples of functions and not functions, and that'll make a little bit more sense. Okay, what do we mean by domain? You keep seeing this word domain. The domain is just the collection of the input values. It's any number that we're going to put into a function. The x's typically is what we're talking about with a function, the x's. Okay. The range is anything that might come out of that function, the outputs. Okay, if you can think about a machine, your domain is whatever you're going to put into a machine, right? I've got some very good friends of ours are farmers, right? So when it's time to they farm corn mostly. And so if you can kind of imagine when it's time to harvest, they take these big harvesters, right? The corn stalk and the cobs are the input into that harvester. What comes out is the feed or the grain or whatever that they use that corn for. Okay, so the output of the what you get out of a function is the y's. It's your range. Okay, now we've got some relations here. And these relations going to represent functions. Okay. If they do, state the domain and the range. And on a lot of these, you have the first one done for you already, right? So this is a relation. We're basically pairing up. So we're going to put 1 into this function, and when we do that, we get 3 coming out of it. Okay. And then if we put 2 in, we're going to get 4 coming out. If we put 3 in, we're going to get 5 coming out. If we put 4 in, we're going to get 6 coming out. Okay. So, is this a function? Go back to the definition of function. For any input, we have exactly one output. For any value in the domain, we have exactly one value for the range. Okay? And for this input, so 1 is an input, we've got exactly one output. For one input of 2, we've got exactly one output. For the 3, we've got exactly 1. For the 4, we've got exactly 1 output. And so is this a function? The answer to that question is yes. Okay? And your reason is because each input has exactly one output. Oops. Okay? And then your domain and range. Okay, and you see it there. Your domain, again, by definition, is any input, so your x's into a function. And so right now our domain is very finite, right? It's just simply 1, 2, 3, and 4. You see that there? And when you're asked for the domain and range, you do want to list them. Now, we're going to get to some functions where the domain and range are too hard to list individually. And so we'll find some ways to write the entire domain and range that way. Okay? And so obviously the range are all of your outputs. And so we got 3, 4, 5, and 6. Okay? All right? What about this guy? Okay, what about this guy? Does this relation represent a function? Think about that for a second. Okay? What do you think? You just learned what that means. And so what do you think? Paul, what do you think? Is that a function? Okay, why? Okay. They meaning? Numbers meaning? Remember I told you before I'm a stickler for vocabulary, right? Okay. What are 1, 2, 3, and 4? What do you call those? Good. Okay. The values of your domain or your inputs. Okay. All of your inputs have an output. How many are they allowed to have? Exactly 1, right? Do all of your inputs have exactly 1 output? Yeah. Okay. So, yeah, we're good. Yes, and for the same reason, right? Okay, each input has exactly 1 output. Okay, now we need the domain. Right, Ryan? What's the domain? You got it. 1, 2, 3, and 4. And the range, Naomi? Okay. Now, not really a reason to list them twice. You can just call it 3 and 4. Okay? Yeah, 3 happens twice, 4 happens twice. There's no reason to write them down twice. So your range is pretty much just 3 and 4. Okay? Good? How about this guy? Think about this guy for a second. Is this guy a function? Skylar, what do you think?
I don't know what I think.
You don't know what you think? Oh, you got to have some kind of thought. Your brain's working. You got brain cells. They're firing. I'm sure they are. Look at your definition of a function. Okay? Think about what we've been talking about. Do you think this situation fits that definition of a function? No? Okay. I got to ask you, why not?
Because there's 2 1s on the domain.
Okay, I don't know what that means, though. Remember, I'm a big stickler for vocabulary. Why is that a problem for us? Look at the vocabulary we got there. The ones are your, what do we call those? Inputs. So you mean that for an input, what's going on? So for the inputs of 1, how many outputs do we have? Can we do that? It be a function? Okay, what's the definition of a function say? For your input, you have to have
Relation as the sign is exactly one value in range to each other value the domain.
it said exactly 1 in the range, right? So we got 2 inputs, and you just told me they go to 2 outputs. Can you do that and be a function? It's got to be exactly 1, right? So I think you're right. This is not a function. Okay? Good. No. Right? The reason is because some inputs have more than 1 output. Okay? Is it starting to make a little bit of sense? The fact that one can go here and basically here. I mean, I know 1 is listed twice, okay? But if we put an input of 1 into our function, we might get 3 or we might get 4. That doesn't make any sense, okay? So we can't do that. So this is no. We can go ahead and talk about domain and range, right? So the domain for this guy, Tommy, is what?
Domain for 1, 1, 2, 3.
Okay? And again, you don't have to write down 1 twice, right? We can just say it's 1, 2, and 3. Okay? And that makes the range, what, Connor?
3, 4, 5, 6.
You got it? Okay? All right? Any major issues or questions there? Okay. Here's what I'd like for you to do. So you're saying yes because, oops. Let's clean that up a little bit. Because each input, right, has what?
Has only 1 output.
Beautiful. Okay? Good. What did you guys come up with the domain?
Domain is 2.
Yep. Range?
3 is 7.
Beautiful. Doesn't matter how many times you list it, right? All the inputs still only have 1 output. Okay? Doesn't matter how many times you list it. Okay? Good. Okay? Is this guy a function?
No.
No? Maggie, what do you think?
I think it does.
You think it is?
Yeah.
Uh-oh. Do you two need to arm wrestle?
No.
Okay. Function or no? Maggie, tell me why you think it's not a function.
I think it is a function.
Oh, sorry. You think it is. Tell me why you think it is a function.
Because each input has 1 output.
Okay. Each input. So if I put 1 into the function, I'm going to get what?
8,
If I put 2 into the function, I'm going to get what?
10,
If I put 3 into the function, I'm going to get what? And if I put 4 into the function, I'm going to get
14,
And 16.
and then 6.
uh-oh. Uh-oh. I don't want to put 4 into a function and get 2 different values. Does that make sense? Okay. So, function? No. Okay. It does look like each input maps to only 1 output because we've written 4 twice. Okay. But we can't do that. Okay? So one input, or you don't have to say one, some inputs have more than one output. Okay? But we can still do domain and range. Okay? Domain, anybody?
1, 2, 3, 4.
You got it. Range?
10, 12, 14, 8, 10, 12.
Well, if you could see it, that's, I mean, you know, that's what it would be. Okay. Anyway. Hopefully that thing will go away at some point. All right, good. Next one. A little different way that we can write our relation. We can write our relation as ordered pairs. That's kind of what the definition is. It's a way to map out pairs, ordered pairs. Your x's are your inputs, your y's are your outputs. So apparently this is telling us that 2 maps to 4, 3 maps to 4, 2 maps to 4, 3 maps to 4. So is this a function? Okay. Definition. Does each input map exactly to one output? Okay. And the answer is, you see it there. Yes, right? Each input has exactly one output. I want to keep saying that. Your notes might say something different. I'm a stickler for definitions. Has exactly one output. Okay? I want to keep talking about that. Inputs and outputs. Domain, you see there? Just 2 and 3. Range. Again, those are your y's. And your range apparently is just 4. Okay? Good? Okay? Cadence, what you guys come up with? Is this a function or not? It is? Okay, tell me why. Okay, each input has exactly one output. If I put 1 into the function, what am I going to get coming out?
A number. Output. A range.
If I put 1 into the machine, I'm getting 7 coming out, right? If I put 3 in, I'm getting 8 coming out. If I put 5 in, I'm getting 9 coming out. If I put 7 in, I'm getting 10 coming out. So I think I agree with Cadence. Okay? Each input has exactly one output. Okay? Domain, Presley? 1, 3. Sorry, I dropped off there. 1, 3. 1, 3, and 2. I don't see a 2.
Oh,
What happened?
I wrote the wrong number.
Okay, it happens. 1, 3, 5, and good. Range. Range. Let me my list on some of you guys. Say it. How about the range? You got it. 7, 8, 9, 10. Okay. Good, 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 good. Next one. What the next one should look like. If you can't see those numbers, let me know. Can't see some of them? Okay. You got -5, comma -1, -4, comma -1, -3, comma -1, Negative 2 comma negative 1. You're welcome. All right, what we got? Function, not a function. Function, not a function. Grace, what do you think? Yeah? Because why, Grace? Good. If I put negative 5 in the machine, I get negative 1. If I put negative 4 in, I get negative 1. If I put negative 3 in, I get negative 1. If I put negative 2 in, I get negative 1. I agree. Okay? That makes our domain. Anybody? Good. And our range? Just negative 1. Okay? Some of you may be starting to see a pattern. Okay? If you end up writing down more numbers in your range than in your domain, it's not going to be a function. Right? That means apparently one of your inputs mapped to more than one output. Right? Okay, there may be some other shortcuts out there for you. Okay? All right? All right. Now, you may not be given the inputs and outputs, and so sometimes you might have to make your own table, your own input-output table. But once you have the table, hopefully it's not too much of a stretch. Once you have the domain, hopefully it's not too much of a stretch to get to your table, right? And you guys, this is basically what you did. Well, you haven't done it yet. This is Algebra 1, right? When you start graphing lines, we start talking about graphing lines. One of the things we'll talk about doing is anytime you try to start graphing something, you can start creating a table, right? An input-output table. So let's do that. Okay? And we give you the domain again of your inputs. Okay? Now, what output are you going to get when you do that, right? Well, we won't know that until we start putting our inputs into our machine and seeing what outputs come out, right? So I'm going to put negative 1 in for that x. And now we're back to the homework from the other night, right? Just evaluating that. So 3 times negative 1 is negative 3. Negative 3 plus negative 7, those are your like terms, get you negative 10, right? You plug in 1. Three times 1 is 3. 3 minus 7, negative 4. And then you plug in 3. 3 times 3 is 9. 9 minus 7 is 2. Okay? There's your input, output. This is definitely a function because if you look, each input maps exactly to one output. And now you've got your domain and range. Okay? Any major issues there? Okay? Make your input and output tables for the next two real quick. Yeah, you got everything there, right? You got your partner there. If you need a little bit of help, you got a partner there. Work with your partner. Make sure you and your partner agree. Okay. Inputs of negative 1, 0, and 2 for number 11 should give us outputs of what, Ireland?
I did the next
Oh, you guys didn't do 11? Braden, help her out.
Negative 2.5, negative 2, and negative 1. Can you just put 2.5?
Yes. You fraction phobes. Okay, negative 2.5, negative 2, and negative 1. Sounds good. Okay? Any issues getting to those numbers? Did I hear a yes? Any issues getting to that number? Any issues getting to those numbers? Okay. Number 12. Okay. Inputs of negative 2, 0, and 3. And so, Jake, we're looking for outputs. Those outputs should be.
I don't know, I was stuck on 11 the whole time.
Okay. Tell me your name.
Ryan.
Ryan. What you got?
Negative 3, 1, and 7.
Negative 3, 1, and 7 should be what you get. Okay? And so we're just plugging all those inputs into in for x, right? And then evaluating. So stick negative 2 in for x, you get 2 times negative 2. 2 times negative 2 is negative 4. Negative 4 plus 1 gets you negative 3. Okay? Jake, does that make sense?
Yeah.
Awesome. All right. Now, if you happen to have the graph of a relation, okay, then you don't have to worry about writing out figuring out what all of the inputs are and outputs, and to make sure that only one input has one output. Or sorry, each input only has one output. You could do something that was called the vertical line test. Okay. A method to determine if a relation is a function or not. If a vertical line passes through a graph more than once, the graph is not the graph of a function. Okay? I'll explain a little bit by the definition of a function why that is the case. But just know it's also called the pencil. I've heard it called the pencil test, where if you put your pencil down and your pencil hits the graph a couple of times, then it's not going to be a function. And I'll show you real quick why not. Okay? Now, are these functions? Okay, and you see there. If we draw a bunch of vertical lines, how many times are those vertical lines hitting the graph? No, each one. Each vertical line, how many times are they hitting the graph? Once, right? And so what we're doing is that for each input, right? Remember your inputs are your x's. This is not the first time you guys have seen the coordinate plane, right? X, Y axes. You guys have seen them before, right?
Yeah.
Okay, just checking. These are your x's, right? So for every x, the way you would find your output is to go to the graph, right? So as long as every vertical line only hits the graph one time, that means that each input is going to only have one output, okay? So it fits that definition. So is this guy a function? You bet. Okay? And the reason is, I'd like for us to keep saying that each input has only one output, but we can just say it passes the vertical line test. Okay? What about this guy? Vertical line test. Anywhere you can draw a vertical line. How many times is that vertical line going to hit the graph? Right, so we're in good shape. Yes, passes, right? But that's why. The vertical line is telling you how your inputs and outputs map out. Okay? What about this guy? No. Right? Boom, boom. Uh-oh, right there. I've hit the graph 3 times right there. So no. Fails the vertical line test. Okay? Good. Okay? Pretty easy way to check if you have the graph. You won't always have the graph, but sometimes you will. Functions. If we've got a function, then we need to understand how to write that out, right? We're in the habit right now of learning how to show or model different situations. If we have a function, then there's what's called function notation. Okay? Which basically is an equation, but instead of using y, we use f of x. That's your function notation. F of x lets us know what we're putting into our function, and when we solve for f of x, it'll tell us what comes out. Okay? That's what we mean by function notation. We're just taking y out and putting f of x in. Okay? Now, to evaluate a function, okay, where are all those numbers coming from before? Well, we had, can I get back to it pretty quick? Right, all these guys. Since this turned out to be a function, all these guys were functions, all we're going to do is take that y out and put an f of x in. Okay? And so it's basically, to evaluate it, we're going to do what we did for those problems. We're going to take our input and plug it into our function. This tells us that our function is defined as negative 3x plus 8. Okay? So, when I put an input in, say 3, that's what we're showing here, right? The input I'm putting in my function is a 3. We read that as f of 3. Okay? Like our function notation, we read f of x. This doesn't mean f times x, it means f of x. Okay? The function of x is defined as negative 3x plus 8. So I want to know what f of 3 is. What's the function when your input is 3? What's your output when your input is 3? And so we're going to do the same thing that we just were doing. Okay? It just looks a little bit weird. All right? So to find f of 3, all right, the function at 3, the f of 3, puberty, f of 3, how do we figure out what the output is? Well, we're just going to plug in 3 for all the x's. Okay? It's like we were doing before, it just looks a little bit different. That's all. Okay? There's nothing to do over here. That does not mean f times 3. There's nothing to do over there. It's just notation. So f of 3, we're going to multiply these two guys together. Then we're going to add those two guys together. And so f of 3, so f at 3, the function at 3 is negative 1. It gives you a value of negative 1. So that tells us that the input of 3 maps to negative 1. Okay? Does that make sense? Notation might be a little weird. But that's all we do. Okay? So we've got some more to evaluate. We're evaluating f still, so we want to evaluate f at negative 5. And then while you're writing, go ahead and write down 18.2, f at 0. Go ahead and evaluate f at negative 5, and then f at 0. Okay? F at negative 5. Did you get 23?
Yeah.
Good. F at negative 5 should be 23. Okay? F at 0. Yeah. 8. Should be 8. Okay? All right? Now, then you have another function at the top, g. G of x is negative 2x plus 9 minus x. Okay? You want to evaluate for g at negative 3. No problem. Right? Oops. All right, we're just going to plug in negative 3 everywhere you see an x. Okay, including, there should be a minus a negative 3, right? You got to make sure you have both signs in there because it's going to make a difference. Right, and we just do our evaluating from before. Negative 2 times negative 3 is 6. 2 negatives make a positive. And so we should have 6 plus 9 plus 3, which is 18. Okay? Next two for you, we would evaluate g at 1/2. And then g of 7. I'm going to choose to believe that you guys kind of have this down. You kind of understand what's going on? Yeah? Okay. But those are the numbers that you need. G of 1/2 and then g of 7. And I'm going to go ahead and tell you that g of 1/2 should be 7.5. Come on. Okay? And then g of 7 it's going to be negative 10. Wait. Negative 12. Right? Okay. Good? Any major issues, questions there? Okay, write this down quickly. Write that down. That's going to be your homework assignment.